Hey everybody, I'm Mr. Hartzler, and I want to talk to you in this video about conics, and specifically we're going to talk about ellipses, which can be a little bit tricky, but hopefully as you go through this with me, and maybe you have to watch this video a couple times, but hopefully by the end you kind of have an understanding, right? I don't expect you to be perfect after the first day, but I do expect that you can do some practice problems with that and check yourself, and then if you end up being wrong, you can talk to me, we can try and resolve some of those issues. So let me share my screen with you, and I'm actually going to share it to a picture first. So we're here. This is what I drew earlier, but this over here on the left side, this is the main formula for it. So over here is our formula, and our center is HK, just like normal. A, though, this is the important part. This, for the top part here, x minus h squared plus y minus k squared, that looks a whole lot like the circle, right? Except now, instead of equaling r squared, it always equals 1. Always for ellipses equals 1. And we have denominators for underneath x and underneath y. If those numbers were the same, it would actually be a circle. But if they're different, that's just saying that they're stretched one way or the other differently than the other one is. So the a value, or the square root of our denominator of x, is going to give us our distance left and right. So that's going to tell us from here over to here, right? That distance comes from the square root of the number underneath x. And it goes from the center to the left side and the center to the right side. And then the square root of the thing underneath y is going to get us b, or the distance up and down. So from my center up to the edge of my ellipse, and from the center down to the bottom edge of my ellipse. And then foci, we'll get to those as we go through the example. So let me end this screen share. And now let's screen share to, or share, we're going to go to the whiteboard. And here we are, and full screen it. Let us go through and do an example, and I'm going to start off with what is actually number 4. There we go. Number 4 on the worksheet I gave to my students. Let me slide my little bar out of the way. Again, number 4. I'm going to look at x squared plus y squared over 36 equals 1. First thing I'm going to do is draw my graph, and I'm going to put in my center. Do some little tags here. 1, 2, 3, 4, 5. I need a 6th. Okay. Now, let us look at the number underneath x squared. Well, it's a 1. Don't think there's nothing there. There's always a 1 there, or a 0. In this case, it's going to be a 1, right? Because I have to divide by the 1 to have it not, or to have it stay the same. So the square root of 1 is going to tell me my distance left and right. Square root of 1 is still just the 1. So that means I'm here and I'm here. Now, if we look at, let's do some blue, the square root of the number underneath y. So the number underneath y is 36. I take the square root of that and I get 6. That tells me I go up 6 and I go down 6. And this is always from my center, no matter where my center is. It just happens because it's a plus 0 and a plus 0 that it's at to the origin. So let me try and, I promise the other times I did this, it was way better. But all right, there's something. There's an ellipse. And we're going to call this a tall and skinny ellipse instead of a short and fat ellipse. So tall and skinny. That means for us that my major axis is this one that runs up and down. So let's first look at distance of major axis. That comes from, again, the longest line through there. And the ends of that, in this case the blue, that's a vertex. And this down here is a vertex. The red ones are co-vertex, or co-vertices, and vertices for the top ones. Okay? So the closest dots together are co-vertices. The ones farthest apart are vertices. No co about them. So the distance of major axis, or the distance from vertex to vertex, my longest distance, my ellipse, is blue dot to blue dot in this case. How far is that? Oh, you can just straight up count them, right, and get 12. You also know that that is 2 times the square root of my largest denominator. Then we have distance of minor axis. The distance of the minor axis is going to be, in this case, 2, but that comes from 2 times the square root of my smallest denominator. All right, cool. We've come a long way, right? We know a lot. I also should write down here my center. It's just good to write it, right? 0, 0. Again, because it was just an x and just a y on the numerators, nothing else thrown in. So now we need to find foci, or that's the plural for focus. So focuses. My focuses, which is also called foci, that's the correct plural, is going to always be on my major axis. I won't do it in red, orange. We'll see if orange shows up. I know it's going to be in here somewhere, because I know it's going to be on my major axis. The question really is exactly where is it? And I'm going to use a formula for this. I'm going to use some words and then some letters. So let's start off here. Oh, orange isn't going to show up here well enough. All right, we'll do black. Major squared equals minor squared plus foci squared. I write it this way because if I were to use A's and B's, well, remember, you guys know A's is always being the stuff underneath X, and B's is always being the stuff underneath Y, and that's not always true, right? I mean, the larger denominator switches around a little bit. That's why I want it to write it like this instead of with the A's and B's. Now, so for this particular case, my A is this 1, but that's my minor, okay, the 1. So, and it's going to be straight up this denominator. So 1 squared is just this number right here. The major squared, the larger denominator, is just that 36, not 36 squared. Don't make that mistake, okay? So this 36 is already squared. I'm going to just pull that on down. I don't know what my foci is, so I'm actually just going to write that in as the letter C, as in cucumber. Yeah, I almost said kookaburra, but that's a K. Anyway, now I need to solve for C. So I'm going to subtract 1 over. 35 equals C squared, square root both sides. So C is going to equal the square root of 35, and that doesn't simplify any further, and I don't have a calculator on me, so I'm just going to leave it as the square root of 35. Hope you're cool with that. That means that from my center, I'm going to go down the square root of 35. Remember, that's really close to 36, so it's probably going to be really close to the number 6, but not quite the number 6. So I probably should have drawn it up just a touch, but we're fine. But because I know it's on my major axis, I know my my x coordinate is not going to change. That's going to stay the same as my center. But my x coordinate is going to stay the same. I think I misspoke there. So my y coordinate is going to change. I'm going to have to add to go from my center up to my foci. So I'm going to add square root of 35. And I also, because I have 2 foci, 2 focuses, I have to add that. So 0, now I have to subtract the square root of 35. That's to then go down and pick up this orange dot. And then I can write my final answer as plus or minus square root of 35. Okay, I hope that was helpful. I know this is a lot of information, but you can kind of walk through that one again. And we're going to go through and do another example of a different type. So if you need more examples like this, please write that in the comments, and I can make a whole nother video just on doing a couple more of these problems. So I'm going to save this one, and then let's clear it. The next example I'm going to do is I'm actually going to go backwards. I'm going to pick up number 1. So number 1 gives me 2 pieces of information. It says my foci are plus or minus 5, 0. And my, what did they write it as? They wrote sum of the distance is 12. All right. So let's draw the things we know. The foci, plus and minus 5, 0. So I'm here. 2, 3, 4, 5, and here. All right, cool. It also said sum of distance. Well, first, I know my major axis is here, right? And probably a little bit past it. Well, definitely a little bit past it. So that is the sum of distance that they're talking about, okay? That sum of distance is 12, so that means from my vertex to my vertex must be 12. Okay, that's talking about major axis length. Major axis length. Okay. And because I knew my foci were at 5, that means this sucker's at 6 and this sucker's at 6. Cool. that gives me a lot of information, right? Let's go down and let's start adding some stuff to the formula that we know. Well, if I creep into the middle, X marks the spot, right? And that's my center. So I'm still at the origin. Backwards. So X minus 0 squared plus Y minus 0 squared always equals 1. Now let's look into the denominators. The major axis length was sum of the distance. They gave me that. And remember, that came from 2 times the square root of my largest denominator. So the 12, if it equaled 2 times the square root of my denominator, well, if I divide by 2, I get 6. Square root of denominator. I square both sides. I kind of wrote it in the wrong spot. So 36 equals my denominator. And remember, that's going to be left and right for us because I was looking at my major axis and it was left and right. So that's a 36. How do I find my missing one, right? I don't know this value here. Well, let us go to our formula. So the major axis, 36, is going to equal my minor axis, let's use it as b squared this time, plus my focal distance squared. So that's going to be 5 squared, right? Because that came from up here on the focus they gave me. So let me simplify that a little bit. 36 equals b squared plus 25. I now need to solve for b squared. So I'm going to subtract 25. Subtract 25. B squared equals 11. Ooh, that's going to be a decimal, folks. 11's prime. Square it. Square it. Oh, you know what? I don't even have to square it. Do you know why? Well, the denominator on my equation is always a squared. It's actually just the straight up b squared number that goes there. So I don't even have to worry about that. It's just an 11. That's cute, huh? So hopefully you picked up on what I did right there, right? I just needed to solve for b squared, not b itself. So I just took whatever b squared equals, which was 11, and put it up here. Awesome. This, folks, is now my formula. And the square root of 11, whatever number that is, it's bigger than 3, less than 4. So 1, 2, 3, 4. So somewhere in here is probably my co-vertex, somewhere in there. And then that gives us our ellipse. Beautiful. And remember, I knew that this 36, had to be my larger number because my sum of distance was 12. So I knew that horizontally was 12, which gave me that 36. But also my foci have to be on my major axis. Okay, so I knew that this horizontal part had to be the bigger one. All right, hopefully that's helpful for you. Let's save it, clear it, and let's try another. All right, so we have, this is number 6. And I have 3x squared minus 12x plus y squared minus 8y plus 10 equal 0. All right, so we have to complete the square here. A couple different ways of doing it. I'm going to do this one. So I'm going to group up all my x's, and I'm going to do them in blue. So 3x squared minus 12x, and then I'm going to do y's in green. Y squared minus 8y. And I'm actually going to subtract the 10 over so that it's over on the other side. Okay, I'm just going to ignore him for a little while. Then I need to complete the square twice. Complete the square twice. Okay. This first chunk, this is the part that a lot of people mess up too because they forget this little step. See this 3 out in front? Can't have that there. I have to factor out a 3 first. So now it's x squared minus 4x plus a blank. Then I'm going to have, and this one's fine and dandy, right? It's already a normal y squared. And we then equal negative 10 plus, and this is going to be a blue line, and then I was green, and then plus a green line. Okay. So what goes on that blue line? Well, negative 4 divided by 2, and then I square it, which is 4. And then the green line, negative 8 divided by 2, and then I square it, is 4, and then 16. So this is a 16. I forgot to write my blue number 4. Awesome. Now I've got to factor further, right? 3, and then this is an x minus 2 squared. I'm just completing the square here. You can kind of follow with me, but you guys have done this before. And then I'm going to simplify everything on the right. 16 plus 4 is 20, minus 10 is 10. And I'll do that in black, I guess. All right, awesome. But I told you, right, we have to divide by that 10 so that we have a fraction everywhere. So I am going to divide by 10, divide by 10, divide by 10. Awesome. Doing well, doing well. So now this is an x minus 2 squared. And the 3 divided by 10, right? How many times does that go in there? 3 1/3. Okay, so this would be like, I'm going to put it kind of as a decimal. No, I'm not. I'm going to put it as a fraction because I hate decimals. All right, so I have 3 1/3 on the bottom. That's how that simplifies, right? It was 3 times, and there's 1/3 left over. Yeah. And then plus y minus 4 squared over 10 equals 1. So that's my formula. In this case, the major axis is going to be up and down because the number underneath y is my larger number. And yeah, we should be good there. That's center is going to be at 2, 4. My and then you can find major axis length is this 2 times the square root of 10, and minor axis length is 2 times the square root of 3 1/3. And that's pretty much all that we need to know there. Oh, and then the foci are going to be 10 equals 3 1/3 plus c squared. Solve for c, and it's going to be added to the y number here, to my 4. So let's see, let's do that a little bit. Minus 3 1/3, minus 3 1/3, that's what, 7, so 6 2/3. So the square root of that, all right, so it's going to be 2, and then 4 plus and minus square root of 6 2/3. That's my foci. I know leaving it as fractions is a little bit weird, but there it is what it is, and I hope this video was helpful. If it was, please click that like button. If it wasn't, then don't watch it again. I don't know what to tell you. If you have suggestions on how I can make this better, or if you need to see more examples, type that down in the comments below. That'll help me know what videos you need to make next. And if you're one of my students, if you have questions, please email me. I'd love to be able to help you. And I can always hop on here with Zoom and do a live chat with you. And I think that can be very helpful and very beneficial. So hit that like button, folks. Subscribe to the channel if you want to see more like this. And have a phenomenal day, all of you. Bye, everybody.